Hello everyone, welcome to Nathan Academy. Today we are going to look at another Leetcode medium problem. Problem name is called add two numbers. This is again one of the highly popular question that is asked across Amazon, Bloomberg, Apple, Adobe, Microsoft, Google, Facebook. So it's a pretty good question. Let's try and go over the question first. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of these nodes contains a single digit. Add the two numbers and return the sum of as a linked list. You may assume the two numbers do not contain any leading zeros except the number 0 itself. So basically we need to say we have given two linked lists and we just need to add those representative numbers and return a new linked list. So the very first example they have given is 2, 4, 3, the elements of first linked list, and second linked list elements are 5, 6 and 4. So we need to add 2 and 5, that's going to become 7. We need to add 4 and 6, that adds up to 10. We need to carry over 1 to the next element, so add 0 here, and this is 3 and 4, which is 7, and we had 1 carryover, so 7 plus 1, 8. So that is what it is here. The result that we need to return is 7, 0 and 8. Let us look at another example where both L1 and L2 are 0, in which case we need to return 0. And third example is like 9, 9, 9, 9, 9, 9, 9, and this one is 9, 9, 9, 9, and the result is going to be like 8, carry over 1 to the next one, that is 8 plus 1, 9, again carry over 1, 8 plus 1, again carry over 1 more 9, again 8 plus 1, 9. So once we cross these 4 digits, these does not have any matching numbers to L2. So we're going to just add 9 plus 1, 10, which is going to be 0, add to the next one. So remaining keeps 0 and the end we just append the 1. Let's quickly jump onto the whiteboard to see how to proceed ahead with the problem. Let us quickly do the addition of the numbers provided in the Leetcode problem examples. So the first example, linked list 1 contains the elements 2, 4 and 3, and linked list 2 contains the numbers 5, 6 and 4. So this is a pretty straightforward arithmetic additions. So we just need to start processing the numbers from left to right. If you see here, 2 plus 5, that is equal to 7. 4 plus 6 is 10. We need to add 0 and carry over 1 here. Then it's gonna be like 4 plus 3, which is 7, plus 1, which is 8. This will be the result of the first example. The second example being a 0 and 0, we just need to return 0. And for third example, where interesting case, the number of elements in L1 is greater than the number of elements that's present in L2, but the addition is pretty much still the same. We just need to keep adding and keep carrying forward the numbers. So if I do 9 plus 9, which is 18, I need to create an 8 here and carry one more. So 9 plus 9 is 18 plus 1, which is like 19. So you need to do 1 and carry 1 forward. And again 9 plus 9 is 18 plus 1, which is going to be 19. You carry forward another number, which is again gonna be 19. You carry forward 1. 1 plus 9 is 10. So you're gonna add this number and carry forward 1. And again 9 plus 1 is 10. You add this 0 and carry forward one more number. And this again is like 9 plus 1 is 10. 0. You carry forward one more number. Since there are no more numbers present in that position, we just add the number 1 over here. So this would be the respective results that we need to do over here. So let us quickly go over different cases of the problem itself. So here we have just 3 cases that we need to cover. Sorry, this is pre-populated because my previous recording failed. So case 1 where L1 and L2 contains a number and carry could be either 0 or number. So in which case the result is L1 plus L2 plus carry. For case 2, which we have seen in example 3 over here, um, L1 could be the longest and L2 could be the shortest, in which case L1 might contain a number and L2 can be empty, and carry can be 0 or n, in which case our result is just a math addition of L1 plus the carry. And vice versa also remains true. In case of case 3 where L2 is longer than L1, in that case L1 could be empty, L2 can have a number and carry can have either 0 or a number, in which case the result is obtained by adding L2 plus carry. From this we understand that we need to keep adding the numbers until both L1, L2 and carry gets to 0 or empty. Now let's quickly jump over the implementation in Leetcode. So let's get started with the implementation of the solution that we discussed in the whiteboarding session. I'm going to initially create a temporary list node that will be used to store the result that I'm computing so far. So that's going to be list node. I call it as head and create new list node. Why I'm creating list node with element 0 is like instead of me creating the first node and then updating the address, I create a dummy entry, the first entry with 0, and keep adding the results to the rest of the nodes, and when I return it will be head.next, so it makes things easier for me to handle. So that's the reason I'm initializing my result such way. And I create another variable called result that actually points to the head. There's a small typo here. Once that is done, I need to initialize another variable that's going to be carry, which is going to do like when I add the element of L1 plus L2 and whatever is more than 9, I use it for carrying in this variable. And initially this variable will contain result of 0. Now we need to do this computation until as long as we have any element either in L1 or in L2 or in carry. So that's going to be represented in line 18 in a while loop. And I need to do like if L1 is not equal to null or L2 is not equal to null or carry is greater than 0. So as long as I have any element either in L1 or in L2 or in carry, we need to do this computation. Whatever the addition value that I'm getting, I need to store it initially in a variable called int resval. I need to add L1 plus L2 and carry. And also note that at when we enter this computation, L1 might be null or L2 could be null. So we need to handle those conditions too, which could be easily done using Java's ternary operator. So if L1 not equal to null, I can use the L1 dot value, right? So that's what I'm trying to do here. If not, I just make it 0. And same goes for L2 too. If L2 is not equal to null, meaning like I can use its value, or I make the value as 0 and do that, and then add the carry. So this is gonna actually add all the values that's present in L1 and L2 and carry. If any of the elements are absent, I'm gonna add zeros. Since the problem says it's a positive number addition, we need not worry about any negative implications, and hence I can get away with this sort of implementation here. Once that is done, the next obvious thing to do is like I need to ensure if a value is more than 9, I need to add just the first part, and next has to be added into the carrying part. So that could be like I'm adding this result itself in result dot next, that equal to new list node, and whatever the value I have computed so far, modulus 10. So this would just carry values lesser than 9. And then I also need to update my carry variable, which is going to be divided by 10. For readability purpose, let me move these things to separate line. So once this has been done, the next thing I need to take care is move the pointers, in which case L1 would become L1.next unless L1.next is not null. So if there is a next element, move it to the next element. If not, keep it the same way it was. So that can be achieved using this part. If L1 is equal to null, then I don't move L1 pointer at all. But if not, I'm gonna do L1.next. And I need to do something similar for L2 too. If L2 is null, don't move the pointer, else move the pointer to the next. And remember, we also need to move our results pointer once we update the result. So that's going to be result equal to result dot next. So I have done the computation. Then computation is done at line 19. Then carry and having this a single digit in a given variable is done in line 21 and 22. The pointers are moved in line 25 to line 27 for L1, L2 and the result. So once we do this, all the results are in place and we just need to return the result that we have computed so far. That's going to be return head dot next. Now let us quickly try and run this code to see if it works. It does work and the solution is fine. Let us go ahead and submit it to ensure it is accepted. Yes, it is accepted and is a successful solution. The runtime complexity for this is going to be like a length of m plus length of n. So that's going to be the runtime complexity. Thank you for having a look at this video. If you like this, the way of explanation and everything, consider subscribing to my channel. And if there is something that I could do better, please leave your comments and feedbacks. Thank you.